All right, here's part 2, and here's a couple weird ones. The square root type of problem, our game plan will be to, we want to get rid of the radicals. So something can cancel. And the way we do that is we multiply by the conjugate. Now, I know you've heard that word before because you used it in Algebra 2 and pre-calc. The conjugate is basically when you see the ugly part, right? One of these has a square root. The bottom's nice. I'm not worried about the bottom. It's the top I have to mess with. I guess first I shouldn't jump the gun here. I should try plugging in my 0. On top, you have radical 2 minus radical 2. Bottom you have 0. Okay. So now I can get back to what I was saying. The top is the ugly part. And the top has this radical 2 plus x minus radical 2. The conjugate is something you can multiply by that will basically get rid of the ugliness of the radicals. It's kind of like the same idea of, let me flip this back over. When you have two terms and the only thing different between them is a plus and a minus, like x plus 2 and x minus 2, relate to this guy, which doesn't have any middle terms. See how you can multiply these two special numbers? If the only thing different between them is a plus sign and a minus sign, it will get rid of the middle terms. Well, if I can find the conjugate of this and multiply it by it, then I can get rid of the middle terms, which will be the radical part. So I need the conjugate. What's the conjugate to that guy? The conjugate to that guy is recopying it, but instead of minus, making it a plus. So I really write 2 plus x plus radical 2. Now, if that would have been a plus, my conjugate would have simply had a minus in between. I don't mess with the symbol inside. See, it's like I treat these as two separate pieces. The only thing I mess with is that minus sign becomes a plus. That's what a conjugate is. It's kind of like having x plus 2 and x minus 2. Okay? So, if I multiply this guy on top by its conjugate, I can get rid of the radicals. We're going to see. You don't have to believe me. Oops. Now, it would be illegal if I just multiply the top because I'm changing it. But if I multiply the bottom by the exact same thing, it's really like a crazy version of 1, right? Like 8 over 8 is 1, 20 over 20 is 1. Even this ugly thing over this ugly thing is 1. So I'm not really changing the value of the problem. Now let's see what happens. Okay, some magic's going to happen. We're foiling. Now if you want to, the bottom, I'm just going to write the bottom down here. The bottom I'm just leaving alone, right? I'm just leaving x on the outside, and I recommend you do too. These take practice. You don't get good at these just by watching. You got to try a few. So the bottom I'm just leaving next to each other. The top is where the good stuff's going to happen. What do you get when you multiply a radical 2 plus x times a radical 2 plus x? You just get 2 plus x. That's awesome. Okay, right now you're going to start to doubt me because it's going to get ugly for a second. When I have radical 2 plus x times radical 2, seems bad. You're like, but you promised you'd get rid of the radicals. Well, hold on. Hold your horses. And then you have a negative radical 2 times a radical 2 plus x. So that's going to be a minus. The order I write in doesn't matter because it's multiplication. Now you should notice those two are the same except one's a plus and one's a minus. So they're going to go away in a second. The last part, people can still make a mistake even though it's not the hardest thing ever. When you have a negative radical 2 times a positive radical 2, you want to make sure you write minus 2. Because a radical 2 times a radical 2 is 2. It's that negative sign. Sometimes people forget it. Alright. If you mess that up, stuff won't cancel. Alright, so what happens? On top, I have a plus one of these and a minus one of those. That should happen every time. If that doesn't cancel, you done messed up. So what's left on top? There's nothing to cancel yet. You say. I say, please continue to hold your horses, because horses love to be held. Okay, now you should notice something else on top. See how there's a 2 and a minus 2? Ah, aha. So this is really the limit as x approaches 0 of x over x times radical 2 plus x plus radical 2. Remember, we're just working until we get something to cancel. Now you got something to cancel. Now don't be a rookie here. Okay, I have this left over, but see how it's in the bottom? A lot of people will get so excited they got something to cancel that they'll just let this guy float up top. Not allowed to do that. So you're left with 1 over 2 plus x plus 2. Still looks ugly, but as soon as we get something to cancel, I can plug that 0 in, and I'll have 1 over radical 2 plus radical 2, which is 1 over 2 radical 2. That's not the best way to leave your answer. I mean, it is correct and it's done. If you typed in your calculator, that would be the y value it approaches. You could fix it by multiplying top and bottom by radical 2 and get that nicer answer. I don't mind if you leave it like that, though. You've already done the hard work. All right, so that was radicals. Ugly, right? But the goal is conjugate, multiply top and bottom, you FOIL, stuff cancels, stuff cancels, stuff cancels. Finally, you can plug in 0 for x. They all kind of work that way. All right. Last type of problem, compound fraction type, which is a fraction in a fraction. Everyone loves fractions in fractions. So I guess first we should plug in a 0 here. You'll have 1/4 minus 1/4 on top and a 0 on the bottom. All right. What's our game plan on these problems? Anytime you see the old fraction into fractions, your game plan should be, my goal is to combine into one fraction and then multiply by a reciprocal. And once again, something should cancel. Because the 0 over 0 happens now. Until we get something to cancel, it's going to keep being 0 to 0, 0 over 0. I guess I didn't mention that before. In any one of these problems, if you started plugging in a 0 too early before something canceled, you'd still get 0 over 0. I mean, you could try along the way. But all right, so my goal is to get this ugly mess into one single fraction. Okay, so how do I do that? I need common denominators. So let's try to get common denominators. Usually with these problems, I mean, it gets pretty big. So I want to rewrite this guy and rewrite this guy to have the same denominator. So I'm going to rewrite him here and him here. The x is already on bottom. So what's common between an x plus 4 and a 4? Nothing. So you just multiply them. Can you always do that? Yeah, actually you can. You can always just take one denominator times the other. Leave them in factored form. You're going to want that later. It makes things easier to cancel. Now, here's where you got to talk to yourself. You say self, yes. What did I do to the bottom to make it look like that? Well, thanks for asking, self. I multiplied it by 4, so I got to multiply the top by 4. And here you do it again. Self, still here. What did I do to this bottom to make it look like that? I multiplied it by x plus 4, so I'm going to multiply the top by x plus 4. And here's usually where the rookie mistake happens, if people make them. Make sure that minus sign distributes to everything up top. Okay, so I'm going to rewrite this problem. The denominators are still the same. I guess this is an extra step. I didn't really need to do this step. I just distributed. It seems excessive. So the point of that was so I can write them all over one denominator, 4x plus 4. And the top's going to be 4 minus x minus 4. Well, guess what happens to the two 4's? They go away, and you're left with a negative x on top. All right, we have combined them into one fraction. That was our goal. Woo, made common denominators. Now it's a fraction over a single number. Now, it might help your brain if I wrote this bottom as a fraction too. Is it okay to write x over 1? Sure is. So when I have a fraction divided by a fraction, I'm allowed to take this. Dividing by x over 1 is the same as multiplying by its reciprocal. So I can rewrite this problem as negative x over 4 times x plus 4 times the reciprocal of this guy, which is 1 over x. This is where our canceling happens. See how that cancels there? Don't lose your negative sign. We're almost done. Negative 1 over 4 x plus 4. Now I can plug into 0 for x. I get negative 1 over, don't say 8, it's 4 times 4. So negative 1/16. All right, so there it is. That is, remember, what we're finding every time. A limit is the number that this approaches as x gets closer and closer to 0. It's never allowed to actually get to 0 because it would make this happen. But as it gets closer and closer, it gets closer to that answer. All right, then go through these, start on your homework, and then you can take tomorrow to do it too. And send me a question if you have it. All right, talk to you later. Bye.